Happy. All right, we're going to go ahead and get started with lesson 1-2. Make sure you have the guided notes out in front of you. So in your guided notes, it says blank blank contain numbers, at least one variable, which is a letter, and an operation. It can have one or more operations. So in the guided notes, you should be putting algebraic expressions.
So an algebraic expression is like a numerical expression.
Under examples, you can go ahead and put 3x plus 4y plus 12. You could also use
so they have to be represented by a variable
5x.
instead of a number.
This is an algebraic expression because it has a number, a variable, and the operation here is multiplication. We just do not put the dot there or to represent multiplication because we get a little lazy and we just write 5x. Let's go over the key terms in an algebraic expression. A variable is a letter that represents an unknown value. So our variables here are x and y. X could represent any number. Y could represent any number. So an example could be x could equal 5. It could equal 10. It could equal 1 million. Y could be 0. Y could be negative 55. We don't know what the value is, so that's why we use a variable. Next is term. A term, a number, a variable, or the product of a number in one or more variables, separated by a plus or a minus sign, as long as the plus and minus sign are outside the parentheses. So the basic definition is a term is separated by a plus or a minus sign. So if we look at this algebraic expression, they're separated by a plus sign here and a plus sign here. So this algebraic expression has 3 different terms. And next we have a constant. A constant is a term that contains only numbers. We know that this is always going to be just 12. So a constant is just a number. Lastly, we have coefficient. Coefficient, the number part of a term with variables. So the coefficient is the number in front of the variable. So the coefficient for 3x is 3. The coefficient for 4y is 4. So the coefficient is always the number in front of the variable. All right, I've given you another algebraic expression here. 5x minus 3 parentheses x plus 1 close parentheses plus 14. So let's try to find the variable. The variable in this case would be x and x. It is a value that we do not know, so we give it a letter. Let's find the term. How many terms are in this algebraic expression? What I like to do is I like to circle the different plus and minus signs, other operations that are plus and minus signs that separate to create terms. I will not include this plus sign because it's inside parentheses. So I have 1 term, 2 terms, and 3 terms. Next is our constant. The constant in this problem is, what do you think? If you were thinking 14, you are correct. Nice job. The constant is 14 because it's just the number 14. We are adding just 14. It's in its own term, so we know that term is always going to be 14. Okay, the coefficient now. Remember, that's the number in front of the variable. So the number in front of the variable, coefficient, we have 5. 5 is a coefficient. We have another variable here. It's just x. So how many x's do we have? We have 1 x. So we get lazy in math, and when we have just 1 x, just an x here, the coefficient in front of that is a 1. We just don't normally write it. So our coefficients would be 5 and 1. Next, we are going to move into part 1 of your guided notes. It says label each expression with an NE for numerical expression and an AE for an algebraic expression. Remember, a numerical expression is going to have just numbers and operations. Algebraic expressions are going to have variables, which are letters, numbers, and operations. So go ahead and give those a try. Remember, NE stands for numerical expression and AE stands for algebraic expression. All right, I have separated these into numerical expressions and algebraic expressions. If you notice these 4 over here, they are all numbers and operations. We can solve all of these problems. If we go to algebraic expressions, you notice they are numbers, we have letters, and different operations. All of these algebraic expressions, we cannot solve them because we do not know the value of some of the numbers. So again, make sure you have labeled each of them on your guided notes, numerical expression or algebraic expression. We're going to go ahead and move on to part 2 of your guided notes.
A quantity is something you can measure, like how many inches of rain will fall right here during this storm. I can measure it as soon as it stops raining. A variable quantity is a quantity that varies or changes, like how much it will rain here for a whole year. That amount will change from year to year and even from day to day. Quantity, variable quantity.
Okay, in your guided notes, make sure you are filling that out. We should be putting in a quantity, write this in your guided notes, is something that you can measure. We know what the answer is going to be. We know that it rained 2 inches. For the second one, you should be writing variable quantity. This is a quantity that varies or changes. So how much rain do you get each year? Well, it changes from year to year, so we do not know, we cannot measure how much rain you're going to get every single year. Okay, that is going to change from year to year. That makes it variable. Let's give some examples of quantities and variable quantities. And we're going to talk about cell phones. I know most of your favorites. Cell phones. The problem says, you have a prepaid cell phone. As you talk on the phone, the number of minutes you have left decreases. When you get below a certain number of minutes, you have to buy more. So this is a type of cell phone plan that you can purchase. My dad actually has a plan like this, and he uses a flip phone. Crazy, huh? He doesn't own one of those smart things. So let's go ahead and fill in the blanks and then identify which quantities are variable quantities. So A, the number of minutes available on the phone. So let's go ahead and write minutes in here, the first A. Draw this quickly. Minutes. B, the cost per minute to buy more minutes. C, the amount of money. and that you spend buying minutes, and D, the number of minutes you use per call. So I know most of you think this as a hashtag, but it can also be used as number. Okay. They go in order. Minutes goes to A, cost goes to B, money goes to C, and number goes to D. All right, when you purchase, so let's go. Are we going to have a quantity or a variable quantity? The number of minutes available on the phone. So if you look at your phone, it's going to tell you how many minutes you have left, so we can measure that. So this here is going to be a quantity. I'll put a Q next to that. The cost per minute to buy more minutes. When you go to the store to buy more minutes, it's going to give you a cost. We can measure how much that cost is. It's going to give us one specific answer at that store. So again, this is going to be a quantity. It's going to be one answer. C is the amount of money you spend buying minutes. Okay? We're going to count this as a quantity because once you go to the store and buy them, you bought that amount. You can measure how much money that you've spent buying minutes. Lastly, we have the number of minutes you use per call. Okay, so if you call, let's say, your brother, and you don't really want to talk to your brother, it might be a quick phone call. But let's say you want to talk to your grandma, and it's a nice long chat with your grandma. That might last longer than maybe your annoying brother. Okay, so the amount of minutes per call is going to change each phone call. So this is called a variable quantity. Around the holidays, hopefully your phone calls might get a little longer because you want to talk with family about the holidays. Again, quantities are going to be something that we can measure. Variable quantities are something that's going to change. We don't know. All right, let's go ahead and move on to the next problem. I'm going to read it to you, then I want you to take some time to try to solve for it. So it says, Tyson takes the same route to work every day. He drives 15 miles to work each day. The amount of time it takes him to drive the 15 miles changes from day to day. There are 5 stoplights on the drive. If a stoplight is red or yellow, he stops at the light. If a stoplight is green, he does not stop. He also pays $3 for tolls each day. Which of the quantities listed below are variable quantities? Circle the variable quantities. So please go ahead and read through those options and figure out which ones you think are quantities or variable quantities, then we'll go over it. All right, let's start with A. The number of miles he drives to work each day. Can we measure that? Does that change? No, that stays the same. It's always 15 miles. So A, the miles to work is a quantity. We can measure that. B, the amount of time to drive. All right, there's a typo on that. It says, so the amount of time to drive to work. Okay, is that going to be the same every day or is that going to change? It is going to change. It's going to vary. So it's a variable quantity. So it all depends on how many lights he hits. If you hit all green lights, which would be the best thing ever, you're going to get to work really fast. But if you get stuck in those red lights, which is so frustrating, it's going to take you a lot longer. C says the amount of money spent on tolls each day. Right? In the problem, it says he also pays $3 for tolls each day. That is going to be a quantity because it's always $3 every day. You're going through the same number of tolls every single day. There's no way around them. Lastly, the number of stoplights he stops at. Like I said earlier, it could be a really good day where you don't have to stop at any of them, or it could feel like a Monday and have to get stopped at every single red light. So D is going to be a variable quantity. Okay, we're going to move on to the last part, which is part 3. We're going to identify the factors in the expression below. So in the expression, we have 6, parentheses mean multiply, so this is 6 times 5. This would also be a numerical expression because it has just numbers and operations. So we're looking for the factors. Factors are numbers that you multiply. So we have a 6 times a 5, so our factors would be 5 and 6. How you would enter this in MathXL, you would put in 5, 6. You just write the factors and separate them by a comma. Okay. The next one, we have 7, parentheses, x plus 16. What are the two numbers that we are multiplying? One of them is definitely 7. The other one is, since it's in parentheses, you're doing x plus 16. You're multiplying 7 by that. So you're going to write 7, comma, x plus 16. So on MathXL, this is how you would type that in. There are questions like this on the homework. All right, next one, we have 22 times 59 times 11. The factors would be 22, 59, and 11. Why don't you go ahead and try the last two here, right? The factors for both of these are algebraic expressions. All right, for the algebraic expression, 8 parentheses z minus 4. The factors would be 8, 8, comma, z minus 4. You're multiplying 8 by z minus 4 since they are in parentheses there. This is one factor. All right. The last one, we should have 3 as a factor, comma, then we have y plus r divided by 2. These are your two factors here. This slash represents division. That should be everything for lesson 1-2. Please make sure you're reaching out to your math teacher if you have any questions. Have a wonderful rest of your day and make sure you're completing MathXL 1-2 for homework.